The 1940s and 1950s were a unique time in aviation history, one full of innovation, experimentation, and identity crisis. As the Second World War neared its conclusion, a new type of propulsion was emerging, the jet engine. While still in its infancy, the jet engine was the future of aviation, promising unparalleled speed. It was no secret that European nations were putting vast resources into the research and development of such aircraft, and that once fully developed, these aircraft would be superior to their piston-driven counterparts. However, research data collected from aircraft such as the Gloster E-2839 and Bell P-59 revealed that the new turbojet engine, despite offering potential speed advantages, still had its various drawbacks. These drawbacks would include excessive fuel consumption, which limited range, and slow acceleration, which left the aircraft vulnerable during takeoff and landing, and resulting in lengthy takeoff runs. In the case of the Navy, this meant such aircraft were entirely unsuitable for carrier operations. One solution to the drawbacks of jet technology was to implement a mixed propulsion system. Such a system would, on paper, promise the best of both worlds, combining the fuel efficiency and quick response of the piston engine with the high speed provided by the jet engine. Results would be mixed, with few designs reaching operational status, resulting in some most interesting, yet ultimately flawed aircraft. Not all aircraft with a mixed propulsion system were designed with such intent. Many successful piston designs would retrofit a jet propulsion system, often in pods under the wings, to augment performance in an attempt to remain relevant in a jet-dominated era. Other aircraft would be used as research platforms to study the new technology. Welcome to the Index of Oddities, where we discuss the lesser-known and more unconventional designs that often go forgotten in the skies of aviation history. The first aircraft on our list is perhaps the most well-known piston hybrid aircraft, built from the ground up to take advantage of a dual power plant system. The aircraft in question is the Ryan FR-1 Fireball. The story of the Ryan Fireball begins in 1943, when Admiral John S. McCain Sr. released a proposal for a mixed-power aircraft to 9 manufacturers. Ryan Aeronautical's proposal, the XFR, was accepted, and a contract for 3 test prototypes and a 4th static airframe was placed in February 1943. The static airframe was to be delivered within 10 months, while the first 2 XFR-1 prototypes had 14 months. The proposed aircraft would incorporate multiple innovations, many to be a Navy first. It was a low-wing monoplane that made use of a laminar airfoil and a tricycle gear undercarriage. It was also the first naval aircraft to make use of flush rivets on the exterior. Up front, it would have a Wright R-1820 72W Cyclone engine, producing 1,350 horsepower, a relatively modest number compared to the 2,000-plus horsepower engines used in the F-6F and F-4U. Mounted in the tail was a General Electric J31 centrifugal flow turbojet, producing 1,600 pounds of thrust. Something important to note here: the Bell P-59, the Air Force's first jet fighter, was powered by 2 GE J31 engines, while being nearly identical in overall weight to the FR-1. As the Era Comet had already proven to be underpowered, we can already see where things will go with the Fireball. To simplify the fuel system, both engines would be configured to burn the same octane avgas. Engine controls would be designed so that the pilot could operate each engine independently or operate both simultaneously. The cockpit was enclosed in a streamlined plexiglass canopy installed forward of the leading edge of the wing, offering greatly improved forward visibility over contemporary fighters. Prior to the first flight, a 1/5 scale wind tunnel model would be tested at NACA, Langley, Virginia. These tests would reveal that the XFR-1 would have poor longitudinal stability with the original tail. Another problem revealed by the wind tunnel testing showed that the double-slotted flaps would not provide the necessary lift when deployed. Despite these discoveries, limited testing, within restrictions, would commence with the original tail and flaps. The initial test flights for the Fireball began on the 25th of June, 1944, where Ryan's chief test pilot, Robert Kurlinger, made 2 test flights that day without the jet engine installed. Immediately afterwards, that engine would be installed, and several flights would be conducted in July, with both power plants installed. For such an unconventional design, the XFR-1 flew surprisingly well, with very few major issues to correct. one of which goes back to the flap issue revealed during the wind tunnel testing. The double-slotted flaps provided an unacceptably high descent rate when deployed to 55 degrees. These flaps would only be fitted to the first 14 units built, with subsequent units being fitted with single-slotted flaps limited to 40 degrees of deflection. The top speed of the Fireball varies depending on source, ranging from 404 to 426 miles per hour at an altitude of 18,000 plus or minus a few hundred feet. Even taking the more generous estimate, the Fireball still proved slower than contemporary Navy fighters. However, it did display surprising maneuverability and desirable climb performance. It would also have been capable of engaging enemy aircraft at any altitude, as its performance was largely independent of altitude. The Fireball would go on to see 71 units built, including the prototypes. It would serve with the U.S. Navy from 1945 until late 1947, though never seeing combat. Unfortunately, after being withdrawn from service, all FR-1s were scrapped, with the exception of examples retained for testing. Today, only a single example exists. Formerly operated by NACA, it currently resides at the Planes of Fame Museum at Chino, California. Next up, we have the Curtiss XF-15C, Curtiss's lesser-known response to the same proposal that brought about the Ryan Fireball. On paper, the XF-15C had more promise than the Fireball. Equipped with the noticeably more powerful Pratt & Whitney R2800-34W and an Allis-Chalmers J36 turbojet, itself a license built de Havilland Goblin, the XF-15C was, in theory, the fastest fighter flown by the Navy during its testing phase. Capable of just shy of 470 miles per hour, it was capable of keeping pace with even the fastest non-jet-powered Air Force fighters of the period. Much like the Fireball, the XF-15C would also use a bubble canopy and a laminar flow wing to decrease drag and increase performance. The first prototype performed its maiden flight on February 28, 1945, with only the radial engine installed, mirroring the test flights of the Fireball. By May, the J36 turbojet would be installed, and further testing would continue. Unfortunately, the first prototype would be destroyed in a crash during the early phases of the test flights on May 8, 1945. The second prototype would be ready for trials the following July, which revealed vibration and stability problems. In an attempt to correct these issues, the entire tail assembly would be redesigned, with a new, unconventional T-tail installed. The vertical tail surfaces would also be enlarged. Despite these modifications, the shortcomings of the XF-15C persisted. Both the second and third prototypes showed promise. However, by 1946, the Navy lost interest in the mixed power fighter concept, as the rapid development of the jet engine eliminated the need for such composite aircraft. The XF-15C unfortunately marked the end of Curtiss's career with the Navy, being Curtiss's last aircraft developed for the Navy. Despite the legendary status of the name Curtiss, the company was plagued with numerous problems, producing several well-known aircraft that gained a reputation for poor quality and workmanship. Of the two remaining prototypes, one would be scrapped shortly after the cancellation of the program, while the other would remain in storage. Today, the sole survivor is currently on static display at the Hickory Aviation Museum in North Carolina. Fighters were not the only designs to trial mixed power systems. It was also considered for use in torpedo bombers, such as the Grumman XTB3F. In an attempt to replace the heavy and underpowered TBF Avenger, Grumman proposed multiple designs based on the obsolete airframe, but none of the proposals could satisfy the Bureau of Aeronautics, resulting in Grumman dropping all consideration of retaining any commonality with the Avenger. Grumman proposed multiple configurations of their new concept, internally designated G70. Most relevant is the G70F, which called for a Wright R3350 and a Westinghouse 24C turbojet. Calculated performance with both engines running promised a top speed of 394 miles per hour at sea level and an initial climb rate of 4,880 feet per minute. This offered a substantial performance increase over the TBF-3, the standard version of the Avenger. The G70F also promised superior performance to other G70 proposals with different engine configurations. By this time, the G70F had caught the Navy's attention, and the project was assigned a high priority. In October 1944, a mock-up of the G-70F, now designated XTB3F1, was ordered and Grumman was quickly supplied with the necessary equipment. This included a mock-up of the Westinghouse turbojet and a new four-bladed Curtiss propeller. For those of you already aware of the history of the duplex Cyclone engine, it may come as no surprise for you that the XTB3F1 ran into delays, resulting in the Bureau of Aeronautics requesting Grumman to prepare revised performance data on lower power engines. The new engine requirements would call for the Pratt & Whitney R2800 34W and a Westinghouse 19XB turbojet. The revised performance data resulted in a 7% reduction to top speed and a 62% increase in takeoff distance. Despite the loss of performance, Grumman was ordered to complete 3 XTB3F1s with the revised power plants. Only 4 months after the revised configuration was ordered as prototypes, the instructions were once again revised in July 1945. The new revision demanded that the second prototype be fitted with the initially planned R33 5026W and W24C engines, now designated XTB3F2. However, further engine delays prevented any of the prototypes from being completed before Japan surrendered in August 1945. With the conclusion of the Second World War, the XTB3F project lost its priority status, with work on the first prototype continuing at a reduced pace, while the second two were held back pending Navy requirements. It would not be until December 1946 that the XBT3F1 would take its maiden flight. The following day, the Navy would send a stop work order. The Navy no longer had a need for such a large two-seat torpedo bomber, meaning the XTB3F was redundant. However, the need for a carrier-based ASW aircraft was a priority, resulting in the XTB3F project being revived once again. Grumman was instructed to complete prototypes 2 and 3 as the XTB3F2S and XTB3F1S, respectively. It was at this point the turbojet would be removed as it was not required for the ASW mission. While the XTB3F never went into production under mixed power, it would directly lead to the more familiar AF Guardian. With the conclusion of the Second World War, the Boeing B-29 Superfortress was the only aircraft then capable of delivering a nuclear payload. The Navy, not happy with the Army Air Corps' complete control over the nation's nuclear strike capability, developed the argument that the U.S. Navy could better serve that role. The argument was, the B-29 lacked the range necessary for an intercontinental strike, while the B-36, then in development, would need escort fighters, requiring overseas land bases. The Navy's proposal was a carrier-based, high-speed medium bomber that would fly just above sea level to avoid detection. The idea was to build the transoceanic range into the carrier rather than the aircraft, allowing for a smaller, higher-performance aircraft to fulfill the same role. In 1945, the Navy opened a design competition for a medium-attack aircraft capable of carrying a 10,000-pound payload. This request was made independently and was not related to the Navy's desire for a nuclear-capable bomber. However, it was noted that the Mark III nuclear bomb dropped over Nagasaki, nicknamed Fat Man, weighed in at just over 10,000 pounds. North American Aviation won the competition with the submission of the XAJ Savage. After discussions between North American Aviation and the Bureau of Aeronautics, it was decided that the AJ was suitable to be modified to carry the Mark IV atomic bomb. The Savage is the first 3-engine aircraft on our list. It would make use of 2 Pratt & Whitney R2800 44W radial engines and a single General Electric J33 turbojet. As was common in these mixed-powered aircraft, all 3 engines were configured to burn the same grade avgas, simplifying the fuel system and allowing them to utilize the same fuel tanks. When the turbojet was active, air was supplied through a small door just ahead of the trailing edge of the wing, in a dorsal position on the fuselage. The J-33 turbojet would only be used for takeoff, high-speed operations, or in the case of an engine failure. In June of 1946, North American earned a contract for 3 XAJ-1 prototypes and a 4th static airframe. Fond of the project, the Navy placed a production order for 12 units in October 1947, an additional 28 units in May 1948, despite the XAJ-1 not yet having flown. It would not be until July 3, 1948 that the first XAJ-1 prototype would take to the air. Production would soon begin, with the first production AJ-1 taking its maiden flight in May 1949. When in complete working order, the Savage was well liked, as it had favorable handling characteristics. However, it often ran into reliability issues. On the carrier deck, it was not so popular, as it was large and cumbersome, and the wing folding process was a time-consuming one. It would see a short but diverse service life, serving with the Navy between 1950 and 1960, filling roles as a medium bomber, reconnaissance aircraft, and aerial tanker. NASA would also operate 3 AJ-2s as weightlessness simulators for astronaut training. In civilian use, one even saw service as a water bomber before being purchased by Lycoming to test turbofan jet engines. North American attempted to further improve the Savage into the XA-2J Super Savage, an aircraft that was doomed by engine issues and its inability to match the performance of the Douglas XA-3D. Unlike its predecessor, the Super Savage was not a mixed-power aircraft. As the only four-engine design on our list which was designed from the outset to use a mixed propulsion system, the Martin P4M Mercator stands out amongst other entries. Not only did it make use of two Allison J33 turbojets, it also called for two Pratt & Whitney R4360 Wasp major radial engines, the largest and most powerful piston engines available at the time. Under the internal designation of Model 219, development of the P4M began in 1944 as a replacement for the consolidated PB4Y privateer. In contrast to most four-engine designs, the P4M would have only two nacelles. The two radial engines would be mounted conventionally, with the turbojets being tucked in the back of the same nacelle, where it was common to store the retracted landing gear. With this space occupied, the landing gear had to retract into the wing, outboard of the engines. The wings themselves were of particular interest, with a wingspan of 114 feet, 4 feet wider than the PB4Y which it was built to replace. More interestingly, the wing used two different airfoil shapes. For the nerds out there, the center section of the wing used a NACA 2417 airfoil, while the outer panels used a NACA 2412 airfoil, more optimized for speed. This would lead to some interesting stall characteristics, where the outer wing sections would stall first. In contrast, a conventional straight wing design stalls from the wing root first. In terms of defenses, the P4M came equipped with an array of heavy 20mm cannons, a rather unconventional choice when most bombers of the era were defended by the popular Browning M2 50 caliber MGs. The first prototype would be equipped with two 20mm cannons in an experimental Martin X220CH2 turret. While not seen in the prototypes, the nose turret equipped on production units would see an identical set of armament in an Emerson nose turret. More conventionally, the waist gunners and dorsal turret would use the aforementioned MG defenses. On September 20th, 1946, the first XP4M-1 took its maiden flight. During this flight, the aircraft was powered by the radial engines only, and the gear would not be retracted. The second test flight would occur 6 days later, showing promising performance. The second prototype would differ quite a bit from the initial one, as it would lose all defenses but the tail turret and install a radar in the nose. This would offer a cleaner and lighter design, allowing for an increase in speed and range. The production P4M-1 would find itself as a mix between the first two prototypes, fitting nose and tail gunners, but removing all other defensive armament. Instead, it would leave space for a camera operator's position, with camera ports in the belly of the plane. It would also fit an Emerson Aero 11B ball turret in the tail, in place of Martin's experimental turret. Performance-wise, the P4M was no slouch. It could reach speeds of 410 miles per hour and could outclimb any piston-driven fighter to 20,000 feet of altitude. Unfortunately, however, the P4M was overlooked in favor of the Lockheed P2V Neptune, a smaller, simpler, and cheaper design. While we will discuss the P2V later on, the Neptune itself was not designed to be a mixed-powered aircraft. It was only after the Martin design proved the feasibility of mixed propulsion that Lockheed later incorporated a hybrid system into the design. Despite favoring the Neptune, the Navy still ordered a limited production of 19 P4Ms, bringing the total number built to 21 when including the two prototypes. The P4M would serve the Navy well, serving for a full decade between 1950 and 1960, only being retired after a series of unfortunate mishaps, combined with the lack of spare parts, preventing the aircraft from serving any longer. That concludes part 1 of our mixed power series. Next time we'll go over designs that were later retrofitted with mixed propulsion, as well as mixed power designs that made use of a turboprop instead of a piston engine. If you like this video, please leave a comment below with some feedback or ideas for future topics. Thanks for watching, and we'll see you next time.